Hello, everyone. Welcome to the inaugural product series. Today, I'm going to talk about how to architect a heterogeneous data platform, whether you have a single data center with multiple clusters, either multiple regions of a cloud, or even multiple cloud vendors that you're working with. Before we begin, a little bit about myself. That's a picture from 5 years ago. That's how I used to look like. I am Adit Madan, a senior product manager at Alluxio. I'm a PMC member, a project management committee member of the Alluxio open source project, where I've been at the company for several years now. As most of you might already know, Alluxio is a widely popular open source project. We have over 1,000 contributors, and the number of contributors is growing rapidly. We have a lot of members on Slack, and it's also been rated as one of the top projects on GitHub. Now, when you're architecting a data platform, you may come across a scenario like this. Now, if your platform is complex enough, you may be dealing with multiple compute frameworks for the different applications that your platform is responsible for. Your data pipeline might look something like what I have on the screen over there, that you may have Spark as the first step, which is after data is being ingested, it's being pre-processed by a compute engine like Spark. Then it's being fed to either Presto, let's say for interactive queries, or a compute engine like PyTorch for deep learning. Now, at the same time, if your organization is complex enough, this platform might be split up into multiple teams or multiple domains as well. Now, team A could be producing all of the data, while team B wants to consume the data. Now, the consequence of all of this is that data is shared across various different things. It's not just shared across different compute frameworks, which might enable your end-to-end application, but it's also kind of shared across different ownership domains. Now, one approach to sharing of data is to make copies of data. Now, copies could be made either using naive tools like a Hadoop distributed copy or just synchronization across different data centers or environments. But we all know that manual copies are error prone, and these are hard to maintain. Not just do they have expensive network costs by high network traffic, you have the additional pain of making sure that once you have a security policy that changes and you want to enforce these governance rules, once the policy changes, now that you have multiple copies of data, it's really hard to enforce the same security policy. Now, instead of the approach of creating copies across different compute engines, catering to the applications that you may have, or even different environments, the solution that Alluxio proposes is that do not make any copies of data to be able to access the data. So leave your data in place, whether it's in one or more of the storage systems in the bottom, regardless of whatever your application is. So it's not just for Presto, it's not just for Spark. So if your platform is catering to applications which are, let's say, custom Go applications, some applications written in Python, or using well-known compute engines like Presto or Spark for analytics. Regardless of the compute engine that you're using, leave your data in place, and Alluxio will provide data access to whatever your application is. And Alluxio provides an abstraction layer across the various different storage systems at the bottom, be it cloud storage systems, on-prem object stores, or even file systems elsewhere. Now, the solution that Alluxio provides, it's applicable across different cloud vendors and also on-prem bare metal or containerized environments like a Kubernetes environment itself. So this slide should look similar for those of you who are familiar with the data mesh concept. It's very similar in that aspect that you keep Alluxio blends in very well with that concept in a way that you do not need to make copies of data for someone to access the data. So just keep that in mind while I kind of go through the next few slides. Now, how is Alluxio able to provide such a platform, which is agnostic to both the compute and the storage engines? So Alluxio provides an abstraction layer with various different APIs. APIs range from traditional APIs like the HDFS API, which engines like Spark might be used to, but more recently we've seen an uptake of usage of the S3 interface to Alluxio, so the standard interface that you might be used to talk to a cloud object store like Amazon S3, and also the POSIX interface for newer applications like deep learning or PyTorch or on TensorFlow or PyTorch, which might be just looking to access local storage, but Alluxio makes storage which is remote in possibly another data center or just in a cloud object storage look like it's local on the cluster, which is actually performing the computation itself. At the bottom, you can see a mix of various different storage systems. Alluxio has different drivers, which it uses to translate from the northbound API, as we call it, the API that the application or the compute engine accessing Alluxio uses, to the API that the storage system is used to. In the past, when we saw the early adoption of Alluxio, Alluxio was translating from the HDFS API to some of the newer object store APIs. Now, times have changed. Object store is becoming, or S3 API is kind of becoming more of the norm. So these days, we see the reverse direction in which Alluxio is, one of the things Alluxio is used for is translating from an S3 API to some of the other APIs that you might have in your data platform. Now, the key thing to highlight over here is that it's a fairly commonplace that different compute engines and the platform evolves every so often, every few years. Now, what this layer in the middle is kind of preparing you for is that once evolution happens, you don't need to make significant changes in your platform. So the evolution could look like, let's say today I'm using Presto, tomorrow I want to use ClickHouse, because it's more optimized for the applications that I care about. And or forms evolution could look like, now today I'm using HDFS, tomorrow I want to use an on-prem object store. Or even further forms of evolution could look like, today I'm using on-premises, I have all of my data and compute residing in a private data center. I want to either extend to a secondary data center in another region, or I want to now start migrating some of my applications to run in the cloud, or some of my data to run in the cloud. Now, for all of these scenarios, which are a combination of cross data center access, either cross cloud or a hybrid cloud kind of a model, Alluxio provides you with the flexibility to make changes without really impacting your applications and having a heavy DevOps burden while you go through this evolution. The product that Alluxio provides, one of the key things of Alluxio is that Alluxio, at the heart of it, is a file system. Now, Alluxio provides access to various kinds of storage that it's abstracting on the southbound side. Alluxio, you can see that the file system that Alluxio exposes is in the middle. That's the one in green over there. So you can see the different directories in the Alluxio file system. We have a directory called data, and we have a directory called users. The directory users is actually backed by one instance of HDFS, which you see in yellow on the right-hand side, which inherits the directories Alice and Bob. But if you look at the left-hand side, that's the more interesting scenario, in which we have a single directory. That directory is called data, and that directory is actually backed by multiple different storage systems. It's backed by HDFS and S3 at the same time. So what that means is that part of the data can reside in HDFS, part of the data can reside in S3, and a single directory in the Alluxio file system namespace is unifying both of these. So in the background, what this means is that you can migrate from a hot tier to a cold tier while you're accessing the data. And this migration is live. So there are no interruptions to applications. This is a really powerful concept, which people customers and users are using Alluxio for, so that they can migrate without interruptions to the application. Now, in the beginning, I said that the goal of the talk was to help design a heterogeneous data platform. And by heterogeneity, what I mean is that there could be a variety, like I said, there could be a variety of compute engines, but also like just a variety of applications that you may be designing your platform for. A common combination that we've seen of use with Alluxio is heterogeneity also means that you have multiple different data centers and you have multiple different clouds that you might be working with. The typical scenario is that you start with a single data center, then you kind of expand into, you start using one public cloud provider and then kind of replicate the same stack across the second cloud provider for all of the benefits that you get by negotiating between two CSPs. Now, an eventual picture with Alluxio looks something similar to this, in which you have an instance of Alluxio close to every cluster or on every cluster which needs access to the data. Now, data could be either in the same region or it could be spanning across a hybrid cloud, as you can see in the left-hand side of this picture. If you look at the instance of Alluxio on the top, it's providing access to data in S3, Amazon S3, but also with data which resides in HDFS at the same time. And the previous slide that I showed you, if you're in the process of migrating some of your data from HDFS to S3, this migration is live. So any of the applications on top, whether it's Amazon EMR, machine learning applications on SageMaker, or newer applications on Amazon EKS, all of these applications do not experience any interruption while data is being migrated across environments. At the same time, a common combination, a common way of using Alluxio is what I have in the bottom, in which there's an instance of Alluxio in the on-premises data center providing access to data which is remote in a public cloud. But no one gets to that picture that I had in the previous slide all in one go. So I have three very specific cases in which people typically start with Alluxio. And in the next few slides, I'll kind of get into what people actually get out of Alluxio by using the platform in this way. Now, the scenario that I have on the left-hand side, it's a scenario in which it's all in the cloud. So think of scenarios where you have, let's say, TensorFlow running on some machine learning applications that you're running with data large enough that it cannot reside on a single node. So it's kind of spanning, it's being stored in a cloud object stored like Amazon S3. Now, Alluxio is providing certain SLAs, it's providing certain caching abilities, and I'll get to the various different features in Alluxio which are used for this purpose. Now, that's one way of using Alluxio. It's fairly simple. It doesn't contain multiple storage systems, but still all in the cloud, there is a benefit to be had by using Alluxio in this way. Now, the second scenario that I have, and I have a user story attached to this one, which I'll get to in a couple of slides, is, as you know, all of the cloud vendors, getting data into the cloud is free, but taking data out is expensive because of cloud egress costs. So Alluxio provides certain optimizations so that you can realize a hybrid cloud architecture in this form. So in the heterogeneity in this case is kind of the heterogeneity between a cloud provider and what you have on premises, so a private data center and a public cloud. And the last one is very similar to case number 2, except that instead of using a public cloud, it's using multiple different data centers. So a scenario that you've seen being used is that when you have, let's say, a private data center in which data is being ingested, but that private data center is overloaded. Now, if there are excess compute resources in a different region, let's say a different region of the country, then you can simply start running applications in a different data center without worrying about the location of data. So Alluxio provides access to data which resides in a primary data center, which is now overloaded. So it doesn't have any more compute capacity so that I can start running my newer applications. So across all of these three cases and what I had on the previous slide, I hope it's becoming clear that the value that this kind of an abstraction layer provides, or this platform that Alluxio has provides, is that to be able to run applications, now you don't need to really worry about the location of data. So you can completely decouple where you want to run your applications with the location of data. So the movement of data, the granularity of data that moves, all of that is handled by a platform across the different data silos that you may have in your organization. It would have been nice to not have data silos in the first place, but as we all know, with the complexity of platforms, especially at a really large scale these days, data silos are inevitable. So it's better to kind of embrace that silos will be there and construct an architecture which stands the test of time, so that while the platform evolves, while the organization gets bigger and we move to newer and better compute or storage engines over time, be prepared for that. Now, just to summarize the key benefits, the first one is the aspect of unification, which I already talked about, where you could have multiple different silos and be able to access them in the same way, not just the same APIs, but also the same security or security policies, for example. So if you have different ways of enforcing authorization, you don't need, you just need to specify them at one location, and Alluxio will take care of enforcing authorization across the various different storage systems that you might have. Now, the second one is really focusing on, first is the caching aspect. Alluxio is a distributed system that is deployed on a cluster, and it uses local resources on the cluster to cache, so that once the data is actually remote and it needs to be accessed, Alluxio will manage certain amount of either memory, SSDs or NVMe, which is available on the nodes that Alluxio is running on, to cache data, essentially. So now once data is pulled into the Alluxio cache, then the performance is as if data was local to the machines that the compute engine was running on. Now, what I mean by data management here is, and I'll also elaborate on this in a slide or two, is where Alluxio is not just a cache. So one of the things that this platform provides is the ability to perform certain data management of operations. And data management in this case could mean simple things like, if I know certain data is going to be accessed and the Alluxio system is able to prefetch data. So this kind of an operation, which we call a distributed load operation, is able to load data and prefetch it in the cache. So that caching is really effective even from the get-go. Now, other benefits, as you can see of the data under the data management umbrella, is when I talked about migration of data across different storage tiers, like across HDFS to Amazon S3, for example. Now, these kind of capabilities are what I mean when I say data management over here. Now, the last one, and I already mentioned this, is just the agility that is provided as your platform evolves, something which can be replicated across private data centers or a public cloud. So this agility kind of is a really unique feature of what Alluxio provides across various different compute engines. So getting to some of the newer developments in the product. So we recently released the latest release of Alluxio, which was Alluxio 2.7 in November last year. And we shared certain developments, especially for large-scale deep learning applications on top of Alluxio. Now, prior to the 2.7 release, we focused on one stage of the machine learning pipeline. And if you, just to establish some terminology, if we break down the machine learning pipeline at three stages, the first stage being data loading and pre-processing, where data which resides in, let's say, a cloud object store like Amazon S3, and you have a Kubernetes cluster also in the cloud, which is responsible for crunching the data, loading data from Amazon S3 to the instances, the GPU instances, which is actually performing the computation, and pre-processing it. Let's say that's phase one, data pre-processing and loading. Then we have the second step, which is training of the actual model. So training is an iterative process. The data is accessed repeatedly. And then now once the model is trained, you kind of finally get to inference. Now, once the model is trained, I drive certain insights based on the model that I have. Now, last release, before 2.7, we had shared certain developments in which we only focused on the training step and utilized just the data caching abilities in Alluxio. So the distributed cache that Alluxio provides for the training step, it was able to cache data locally to the GPU instances, and because of the caching, GPUs are no longer idle, no longer waiting for input as frequently as they were before. So by making sure GPUs are utilized, Alluxio was able to provide something like a 40% reduction in training time and associated cost because GPUs are no longer idle as much as they used to be before. Now, but in this release, specifically, we've extended what we do for a machine learning pipeline to not just the training step. Now, like I said, Alluxio is a system which spans multiple steps of a data pipeline or a machine learning pipeline, including the preloading step, training step, and the inference step. Now, if you don't have a system like this, which is acting as an intermediary between the training compute engines and the storage system, so if you're running training on PyTorch, if you don't have a layer like this in the middle, the typical flow that we've seen being used as is that one option is that you copy data which resides in Amazon S3 to all of the GPU instances. That's step number one. It's serialized. You pre-process it, write it back to S3, and then you start your training step. Now, as this whole process is sequential, it's fairly inefficient. Now, in this release, we focused on making sure that the various steps of the pipeline are no longer sequential. So while you're loading data from a remote data source, you can begin your training process while the data is being preloaded. So because of the parallelization that the Alluxio platform provides, we've seen significant improvement in the end-to-end time for the training pipeline. Now, just now, because of the I/O efficiency that Alluxio provides, GPUs are being now utilized to the maximum extent, and Alluxio is utilizing CPU instances on these training instances to be able to make sure that GPUs are fed. Now, a user story that I have is for a hybrid cloud scenario with Alluxio, and in this instance, we have a user who has multiple different regions spread across the country, and all of these regions are running certain simulations and sharing some test drives, which are first of all collecting data from different regions into a central data lake, which is in Amazon S3. Now, once data resides, is collected from various different regions and is residing in Amazon S3, now the next step is to train certain models based on this shared data. And each region is each scientist in each region is training his or her own model. Now, Alluxio is acting as a layer both for the write step, which was the initial step of getting data into S3, making sure that only what data which needs to move actually moves. And then now once data resides in S3, making sure that with repeated accesses of data across different regions, I'm not moving data around more than I need to. So for a scenario like this, you can imagine because of the caching and management abilities that Alluxio provides, minimization of the network egress cost is a major win, and that's what this particular user saw. Another scenario is across a data center scenario, and I already talked about this a little bit, in which there are two data centers. One is a primary data center, and the secondary data center has excess resources. So in this particular scenario, you can see Alluxio was deployed. So there are two deployment models with Alluxio. One is that Alluxio could be co-located with the compute clusters, or another deployment model is Alluxio is a standalone cluster, which is serving one or more compute clusters with possibly different engines in the same data center. Now, in this model, it's the latter, in which we have Alluxio as a standalone cluster, which is 220 nodes, but it's catering to a much larger compute cluster, so eight times the size. So we have a 1600 node Trino cluster talking to Alluxio, which is a 200 node-ish standalone cluster, and Alluxio is being used to access data which is live in a different data center. And by live, what I mean is that tables, in this case, structured data is tables or partitions are being added continuously into a Hive metastore with HDFS as the data source. Now, what to expect in a scenario like this is compared to simply accessing data remotely, not just are you reducing the network traffic, but in addition to the network traffic, if you just compare the raw performance itself, you can see that at a significantly large scale, you kind of get about 3x performance gains compared to just accessing everything remotely, which has other issues associated with network timeouts and other error-prone scenarios that you may come across. That's all for my talk today. If there are any questions, I'll be happy to answer them now. One question I have on the platform is, what happens if data is being changed out of band in a storage system that Alluxio is accessing? Now, for a scenario like this, Alluxio has different ways of making sure that Alluxio is synchronized with the storage system that it's accessing. So, for example, if you have a data lake residing in Amazon S3, but you have Alluxio on premises, providing access to data which is being changed or mutated in the cloud, Alluxio has a way of synchronizing metadata of files in Alluxio with objects in Amazon S3 on demand. So you could set a policy in Alluxio which says that data cannot be stale, or metadata cannot be stale for more than 30 seconds. So in a scenario like this, Alluxio would, whenever it's you're accessing data at a particular path through Alluxio would say that if the data has not been accessed in the last 30 seconds, I will now go and synchronize that with the object store, which in this case is Amazon S3. One more question that we have is, when Alluxio is used for access across different data centers, how does Alluxio make sure that the network traffic is minimized? So for a scenario like this, where Alluxio is being used across either a hybrid cloud or across different data centers, Alluxio, first of all, chunks data into blocks. So for example, if you have a 10 gigabyte file or a 1 gigabyte file, but you only end up accessing a couple of megabytes from that file, Alluxio would chunk the data into blocks, and only the blocks which were accessed or are going to be accessed is what Alluxio moves from one location to other. So you don't move entire objects or files. You move only what is being accessed. So that's one way in which the network traffic is being minimized. Now, and the other aspect of this is the latency itself. And now, when uh, you have significant latency between different regions, Alluxio also prefetches the metadata so that the latency is not felt, because you would only replicate the metadata and not replicate the data itself. That's all the questions that we have for today. I will welcome you to join our Slack in case you have any follow-up questions. Again, thank you for joining.